to find the height of a tree, a group of students devised the following method. A girl walks toward the tree along its shadow until the shadow of the top of her head coincides with the shadow of the top of the tree. See, here's the girl right here. She started back over here, and she, right here, I'll make a girl. Here we go. There's a girl, and she's walking. It's kind of a creepy looking girl. Anyway, sorry. So I'm just going to do a stick figure. Walking this way. And she just keeps walking till, and the whole time she's looking at her shadow as she's walking this way. And she just keeps walking and walking, and she stops right here when her shadow, the tip of her shadow, matches the tip of the shadow of this tree. So let me fill in some stuff over here. Here's the tree. Here's the girl right here. And the tip of her shadow matches the tip of the shadow of the whole tree. This is the shadow here. Oh, that's the tree's shadow. Right? So she just walked, she started back over here and she walked this way until the tip of her shadow matched the tip of the shadow of the tree. So there we go. Now, they want us to figure out how tall is the tree. Well, first off, can you see that we're going to use similar triangles? Let me come down here and try to draw them. We're going to use similar triangles. So we know that the big triangle is similar to the little triangle. In fact, let me just take out that middle part and put it down here. I think it would be more easy for you to understand what I'm talking about. If I put this down here, like that, so I've kind of separated them. There's the little triangle. This is the girl here. This is her shadow. Oops. Maybe make that better. This is her shadow. And here, over here is the tree. Right? I don't know if I dare try to draw a tree. There we go. So there's a tree. And over here is the shadow of the tree. Okay. So those two triangles are similar. Why? How do I know those two triangles are similar? Well, they both have a 90-degree angle. Girl's standing straight up, the tree's straight up. And they also have this angle here must be the same as that angle there because it's the very same piece, right? It's right here. I just separated out the little girl's triangle, but it's the same left corner angle for both the big triangle and the little triangle. So they have two angles the same. So these triangles are similar by AA, right? The two triangles are similar, meaning one's just a same, so they're the same shape. One's just a bigger version of the other. They're the same shape. The two triangles are identical shape, same shape, different sizes. Same shape, different sizes. And I know the sides are proportional, meaning they're in the same ratio. That's what it means to be similar. When you know they're similar, the sides are proportional. Okay, now there's a couple of booby traps here that they're trying to trick us in a couple of ways. Let me call your attention to it and help you watch out. See how this is in centimeters and these are both in meters? We've got to get it all in the same units. In the end, they want meters, right? They're asking for meters in the end. So let's change 150 centimeters to meters. Do you remember how to convert units? Let me come up here and give you that little, remember that little conversion chart? We had, what was it? I'll put it right here. We had meters in the middle. And then we went to the right. And this was decimeter, centimeter, millimeter. And to the left, we had decameter, hectometer, kilometer. So remember how it works. If you're going from, I'm going to go from centimeters back to meters. That's 2 jumps to the left. So I've got to take the decimal. Now, where's the decimal? Well, it's at the end. If you don't see it, it's at the end. And go 2 places back, 1.5 meters. 1.5 meters. So that's 1.5 meters. Okay, so now it's all in the same unit. So that's the first booby trap. Watch out for that. So that's going to be 1.5 meters. Now here comes the second way we can get tricked on this one. Now we're going to set up the ratio, right? So you could say, oh, okay, I got it. We're trying to find out the tree. Call that x. And I could go x is to 1.5 as 33 is to 3, right? That could be my ratio. X is to 1.5, right? Right side is to right side. X is to 1.5. You know the right of the big triangle to the 1.5. And then 33, right side is to left side. No. You can tell by my tone, you already knew that was wrong. I already told you it was booby trap. But what's wrong? Why is that not right? A lot of people do that, and they get the problem wrong. What's wrong? 33, notice what 33 is. Look carefully at the diagram. 33 is only from there to there. 33 is only this part. It's not a whole side of any triangle. It's part of the big triangle, but it's not the whole bottom of the big triangle. So you can only use whole sides of the triangles, right? The sides. 33 is not a whole side. The sides are proportional. So you got to use the whole bottom. What's the whole bottom? 3 plus 33. 3 plus 33. 36. So x is the tree to 36 as the girl, 1.5, is to the shadow, and that's the 3. So instead of that 33, well here, so that's a better way to go. Just use the 2 triangles right here. X is to 36 as 1.5 is to 3. See how now I'm using whole sides. X is a whole side of the big triangle. 36 is the whole bottom of the big triangle. 1.5 is the girl's height in meters. And 3 is the girl's shadow in meters. That'll work. And so now we cross multiply, diagonal, diagonal. 3 times x is 1.5 times 36. 3x is, I don't know. Let me check my calculator out here. I'm getting 54. So 3x is 54. Last step to finish solving for x, divide by 3. X is 18. X is 18. By the way, I want to show, so that is the right answer, 18 meters. That's how tall the tree is. So they're able to figure out how tall the tree is. That's a way to figure out how tall a tree is. Just have that girl walk until her shadow matches the shadow, the end point of the shadow of the tree. And then we know we've got 2 similar triangles because of the angles matching, right? They both are standing straight up, right angle, and they both have this same angle, this ending angle. So similar triangles, and we know her height. We know she knows how tall she is, and we can measure her shadow on the ground. We can measure how far she is from the tree, and that way we can figure out the height of the tree without ever climbing the tree or getting a ladder and trying to run a tape measure up there. It's a tricky way to find the height of a tree or the height of a building. It's the same deal. Just walk to the end of the shadow till the end of your shadow matches the end of the shadow of the building or the tree. One other thing, I want to go back to the ratio. You might say, well, Mr. Henry, x is to 33 won't work, but could we do x is to 36? Totally. X is to 36 would have been fine, right? X is the right side, 36 is the whole bottom, that'll work, is 1.5 over 3, right? Now I'm doing whole right side, whole bottom, little right side, little bottom. That'll work. If you cross multiply, that's another way to get the same answer. You get 1.5 times 36. See how it's coming out exactly the same as that? 1.5 times 36. 3 times x. See, it's just another way of doing the same thing. That'll work also. There's several ways to do these ratios correctly. There's also some ways to do them wrong. Just make sure you're not using the 33 because he's not a whole side. Don't get fooled by that. They try to fool you by that. Always make sure you're using a whole side of a little triangle or a big, and you'll be fine. So there we go. There's our answer.